Hello everyone, how are you today? This is Joshua Haji, Software Engineer Supervisor here at Pixelate, and I'm here to talk to you about Quasar. So in this video, we're going to talk about the Quasar Framework, what it is, why we should use it, and how we should use it. As always, don't forget to like and share this video. Also, don't forget to subscribe to our channel for more information as well as for the latest updates and tutorial videos. So, let's begin. First, we're going to talk about what Quasar is, why we should use Quasar, and then we're going to talk about how to use Quasar. So, first is, what is Quasar? So, Quasar is an open source Vue.js based framework, meaning it is a framework built on top of Vue.js. Also, Quasar can create responsive websites and apps, similar to what Vue can do as well. But the key difference here is that Quasar can deploy in multiple flavors. Later on, we're going to talk about what those flavors are. So, to demonstrate, here we have a sample code repository right here. Imagine that your code is sitting on a single repository. For example, you have a Git repository for this one. So it's sitting on a single space. Now, in order to build your code for the mobile platform, what we're going to do is usually we duplicate the code repository into another one specifically built for mobile. And then next, if we want to deploy our app as a single page application, what we're going to do again is to duplicate that exact same code repository into another instance solely for single page applications. And again, if you want to deploy to another platform, for example, a desktop application, what you're going to do is usually you duplicate the same code again specifically for a desktop application. So instead of a single repository, you now have 4 repositories with the main one, another for the mobile, another for single page application, and another for desktop application. Afterwards, each repository builds its own output files. For example, for the mobile, builds a mobile app. For the single page application, it builds a single page application. And for the desktop application, it builds a desktop application. So, in order to deploy to multiple platforms, it takes too much effort to duplicate the same code base just to build a single instance or a platform. But with Quasar, things go differently. Because in Quasar, what happens is you only create a single project repository, and then from that project, we compile it, and then it turns into a compiled code, and then from that compiled code, we build it to multiple platforms. For example, we build it as a mobile app, we build it as a single page application, or as a desktop application. Meaning, we can deploy to multiple platforms using only a single project file. So that takes the hassle out of the previous description, right? From the previous diagram rather. So, why should we use Quasar? So, based on that demonstration earlier, Quasar lives by a code, which means that Quasar's philosophy is write code only once and then simultaneously deploy it. So, with their philosophy in mind, they achieved what is usually a problem for most developers, which is building for multiple platforms. So why should we use Quasar? Because of these 3 reasons. First is its state-of-the-art UI that follows material guidelines. Later on, we're going to demonstrate how to use this UI toolkit as well as where to find the resources to use this toolkit. Next is the support for desktop and mobile browsers, including iOS Safari. So, with that in mind, you can just relax, take a deep breath, and continue to develop your app without having to worrying about multiple browsers and having to worry about different versions for each browsers, because Quasar takes care of that. Also, your Quasar app is customizable via CSS as well as extendable via JavaScript, meaning you don't have to worry about applying styles since CSS can be extended easily, or rather can be customized easily, as well as JavaScript can be extended easily. meaning you can plug any type of functionality that you can think of as easy as possible. Also, we should use Quasar because of its zero configuration features, meaning all of these features are already integrated out of the box as soon as you install a Quasar, or rather create a Quasar project, which means that your code uses cache busting, tree shaking, lazy loading, ES6 transpiling, as well as code linting. So combining all of these features, your code is expected and is always a 100% production ready application, ready to be deployed anywhere you want to be, whether it be a mobile app, a single page application, a server-side rendered object, or a desktop application, and so much more. Also, why we should use Quasar? Because of these underlying technologies beneath Quasar, which is Vue, Node.js, Webpack, Cordova, Capacitor, and lastly, Electron. So as we all know, Vue.js is a JavaScript framework, which is one of the most popular JavaScript frameworks out there. Also, Node.js is used for creating a multitude of apps, whether it be a CLI format or a server-side format. Node.js gives us a lot of capabilities in terms of development. Also, Webpack allows us to compile our code into a minified format as well as resolve import and export dependencies without having to worry about it. Cordova is a package that allows us to create apps and deploy them to different platforms, for example, Android, iOS. So Cordova can build your app and then create an installable object out of it that can be installed into Android in the form of APK, and for iOS via the App Store. For Capacitor, it works in the same manner as Cordova with a few key differences. But again, both of them works quite the same. They both create APKs and deploy apps for iOS and Android. Lastly, Electron is used to encapsulate our code into a program that can be installed in any operating system. For example, Linux, Windows, and the Mac OS. So with all these technologies in hand, so the most important question is, how do you use Quasar? So in order to demonstrate, let's go and create our own Quasar app. So here's, as you can see, here's the website of Quasar, and using this is how we start. So since I have mine already installed, I'm going to show you how to install Quasar. So let's get started. We choose Quasar CLI and then we head over here. As you can see, installation is as simple as a single command. So all you need to do is open your terminal with Node.js installed and then type this command, which is npm install-g at quasar/cli. Now you might be asking, what is this CLI? This CLI is basically the toolkit provided by Quasar, which is used for creating Quasar projects, for scaffolding, as well as for building your application using Quasar. So let's try and install ours. Even though mine is already installed, let's still try again. So we type npm install -g at quasar/cli, then press enter. So as soon as npm loads, we will wait for it to install, and then that's when we can start creating our own app. Now that Quasar is installed, we can now create our own project. So first, let's head over to a directory where we can create a Vue project safely. So in my case, I'll use the D drive, and then I'll head over to my temp folder. Now from here, what we're going to do is first create a directory where we're going to install the Quasar app. So let's use this command. Then I'm going to use the folder Quasar app. So and then I'm going to go inside that folder, and now we can start creating our own Quasar app using the following command, quasar create. Next is going to ask whether to generate the project in current directory. Simply say yes, or rather the capital Y. Next is going to ask for a project name. So in this case, what we're going to use is just the Quasar app itself. So Quasar-app. Next is going to ask for the product name. And as it says, it must start with the letter if we're building mobile apps. So to fulfill this criteria, let's just use the Quasar app. Next, it's going to ask for a short product description, or rather project description. So in our case, let's use a simple Quasar app. Next, it's going to ask for the author. So in my case, I'm going to type my nickname. Next, it's going to ask you to pick your CSS preprocessor. So it's mostly your preference, but what I suggest is to use Sass with SCSS syntax. Next, it's going to ask for the features needed for your project. For easier access and for later projects, what we're going to use is Vuex and Axios. Now, with Vuex and Axios, we're going to talk about them at a later video rather, because they tackle different problems and they offer different solutions to specific problems. So we're not going to talk about them. But for this video, we're going to set them up in order to show you how to quickly set up your app and to allow you to create your project in a much faster way. So next is going to ask for a preset for your ES. So what we're going to use is Prettier. Next, it's going to ask you to install project dependencies. So in our case, since we use NPM, we're going to select yes, use NPM. And now, the Quasar app is going to install using NPM. Now that Quasar is installed, then we can finally run the command to start up our application. So let's type Quasar space dev. And now what it's going to do is it's going to compile our application and then serve it to us using Node.js. Since it served our application to us using Node.js, we can use hot reload feature to quickly develop apps without refreshing the page. So as you can see, here is our very first Quasar app. Now, in order to modify this app, let us go to the project directory. So as you can see, here is our project directory. Now, in order to modify it, let's use our favorite IDE or text editor that you might want to use. So let's open the project. So just a short run through as to what the files actually mean. Here is a simple README file, and here you can see the configuration file for the Quasar app itself. As you can see, it has links pointing us to what the option does for easier configuration. For example, this one, the boot files, the CSS files. You have extra plugins here. So here you have options regarding the building of the app. Here you can see the dev server as well, which is the one that serves our app in a dev server, namely this one, as well as some framework configurations, for example, plugins and miscellaneous configurations. Also, Quasar supports some animations, as you can see here. Now, for SSR, what SSR means is basically server-side rendering, meaning these are options pertaining to server-side rendering mode of Quasar, because we can deploy our app not just on the front-end side, rather on the client side, but we can also serve our app on the server side using Node.js. So here you can see the PWA options. So what does PWA stands for? PWA stands for a progressive web app. For progressive web app, you may conduct some smaller researches about this, but what basically it boils down to is it is a application that can be installed on your phone without using an APK. So meaning it's progressive. So as soon as your website or rather application updates, the application updates itself as well. So here you have Cordova options. So Cordova is responsible for building our Android and iOS applications, as well as Capacitor. So Capacitor is the other counterpart of Cordova, which offers the same output but rather using different methods. So for Electron, here Electron is responsible for building our application as a desktop environment. For example, Linux, Windows, or Mac OS. So here we have builder options for Electron, and then here miscellaneous configurations for the Webpack. So here you can see it's a chain Webpack main, meaning we're extending the functionality of the Webpack itself. So aside from that, you can see some configuration files here for Babel. So Babel is our transpiling framework for transpiling our code, as well as a gitignore file. So gitignore basically tells us that when we use source control versioning, for example git, which is as you can see here, all of these files are basically ignored by our git versioning system. So also here you can see some ESLint rules. So ESLint is a code linting tool which is used for cleaning up our code base. As well as here is some ignore files again. So editor config is another flavor of Quasar wherein it dictates how our code behaves and it tells our IDE what to do in order to format our code as we go along and type stuff, for example. So going deeper, you have the src folder here which contains the source code itself, a public directory which is some sort of a directory where we add our static files, for example images and icons, and here you can see our node modules which contains all our Node.js modules. Now this one is an auto-generated folder by Quasar, which is an application level code which is used to create the app and bootstrap the app itself. So if you open this one, you will see this warning. It says here that the file is generated automatically. Do not edit. So let's close that and then let's head to the src folder. So going inside the src folder, you will see several files. Let's start with this one. This is our index.html file. As we all know, the index.html file is the root file of our application. It's where the document itself is created. So as you can see, we have the Q app. This Q app is important later on. If you notice here in our app.view file, you can see that we defined a router view. So router view, for those of you who are familiar with view router view is the place where the route is rendered. For example, if you declare a specific route with an attached component to it, it will get rendered inside the router view. For more information about view router, you can check out the video about view router in the description below. So going back, you can see a store folder here. So this store folder is responsible for the Vuex. Now, what is Vuex? A state management pattern library for Vue.js. It allows us to store data into a single source of truth. Again, for more information about Vuex, you can visit our video down in the description below. In order to expand, here you can see an example module with its specific actions, which is here, getters, which is here, its own mutations, which is here, and its own state, which is here. So what binds them all is the index.js file, where everything is imported as a single object. So with that in mind, it allows us to split our code into multiple logical files, meaning our monolithic file, which is bloated from time to time, gets separated and becomes more cleaner. Next, we head over to the router file. So here you can see the bootstrap file for our view router, meaning this file is responsible for creating our app's view router state. So for more information about view router, again, you can check in the description below. Here you can see the routes of the file. So as you can see, we have a path declared here, which is rendering a specific component with a specific children, which again renders another component. So this object here, as the comment says, is left as the last one. So what does this do? It basically catches all possible routes with no matching components, or rather routes without matching route parameters, and then displays an error 404 view to make it appear as if the file does not exist. So in this directory are the pages. Pages are basically files that are attached inside a layout. So you can imagine that your layout is the container, and then your page is what you insert inside the layout itself. So layout dictates the arrangement of your application, and then the pages dictate where your application currently is. For example, a login page, a home page. So for the login page and the home page, for sure, or rather, a most common practice used is to have the same layout. So as you can see here, we have two pages, an error 404 and an index. So also, if you look at our Quasar app here, this area right here is the index page, and this area is the layout. So going back, here's the layout directory. As you can see, here is our app's main layout. It is the container where we put all of our pages. Next is the CSS folder. The CSS folder contains all our CSS files and styles in Sass format. Now, what is Sass? You might be asking, Sass? Sass. Well, Sass is like their motto. It's a CSS preprocessor with superpowers. Meaning, you can code your CSS styles in a way that it matches a developer's mindset when it comes to styling. So you can create nested styles, chain styles together, or inherit styles. So for more information, you can visit the Sass website to check out what it does, and also to find their documentation there. Next, we have the components folder. So components are small logical sections of a website. For example, you have a button component, or you have a modal component, or a slider component. So what they do is they have a single specific purpose, and they are reusable across different pages. So it makes our code much more smaller, because instead of repeating the similar functionalities onto a different page in a form of copy-paste, we create instead a component in order to be reused in different pages. Now, you can see here the boot directory. Boot directory is basically responsible for initializing specific custom functionalities for your application. So if you use, for example, a Axios, as you can see here, Axios is a way for your application to call API endpoints, which allows you to create connections between your application and the database. So in this case, you can see that Axios is inside a boot file. So what does that mean? What it means is that the moment you start your app, upon initialization, all of these scripts are run. Meaning, by the time your app is loaded, all of these things are initialized already. So it's useful for creating custom functionality or initiating custom functionality before the app even starts itself. So that's what boot files are for. Now, for assets, these are specific assets that are rather, you can treat it as a module injection, for example. Or rather, for example, you have an image. Now, you want to use a source. Now, instead of going to the public directory, you may use the assets instead. Assets are treated as module dependencies rather than static files. Meaning, any asset that we put inside the assets folder gets compiled along with our code. Whereas, in the public directory, nothing is compiled upon build. So, if you add an image into a public directory, it stays as an image. Meanwhile, if you add an asset in an asset folder, it gets compiled including your source code. So they are all compiled into a single bundle, which will later on you'll see when Webpack compiles. So now that we've given you a run through of what a Quasar app is, we can try modifying this instance. So to start off, we can create a basic to-do app, which is, a typical to-do app. So first, you can see that we have a page here, the queue page, which is this one. You can see that it's occupying this specific area, this large box right here. If we remove the image, you will see that it disappears as well, just like that. So first, in order to create a to-do app, we need to create our own simple UI. So how do we do that? First, we head over to Quasar website and then we head over to components. As you can see, it has a lot of components here. We can use avatar, which looks like this, or you can use a loading bar, or rather a bar, which is like this. You have a card, which looks like this. You have chat message, which looks like this. A color picker, which is this one, which is a bit complicated, but yes, they have a color picker. A dialog box, which looks like this when you use it. And they have an editor with a what you see is what you get behavior, which is again complicated, but they have it here. And along with other components, so there's so many components to use here. So just looking at it is kind of daunting already. But it gives you an idea as to how powerful the Quasar's UI capabilities are, wherein you can combine different components together, mix and match them together to create your desired UI. So in our case, let's try using the card. So what it does is we're going to create a simple card. So how do we do that? You click the source here and then you'll see the source code for the exact example right here. So this one looks good, so we can use, I think this one looks okay, so we can grab this section here and then we add it over here. And since it's binding a lorem object, for now let's add Quasar. Now if we save that, if we head over to our app, you can see that here is our cue card, or rather the card itself. Now we need to add some spice to it. First, we need to rename it as a to-do list. Now, what we need to do is a bigger text. So we can create a div with a class of text h6. Now you will ask, what is text h6? So text h6 is a class included in Quasar as well. So if we head over to the Quasar website, scroll down a bit, expand the utils, and then you click the other utils, you will find that there are other utilities as well. So you have date utilities, we have color utilities, DOM utilities, morph, formatter, and scrolling. So there's so many things to choose from here. But what we need right now is a typography. So we go to style and identity and typography. So as you can see, they handle typography as well. So as you can see here, they have specific classes that we can use, which is out of the box and displays a certain output. So in our case, let's use this headline for. So it says here text h4. So let's use that. Instead of h6, let's use an h4. So it says here that it should look somewhat like this. Now if we head over to our app, as you can see, it looks exactly the same. So aside from headings, they also have font weights. So they have bold, they have thin, light, they have helper classes as well for alignment and for italics, and they can change the font as well. So you can add some custom fonts as well, as you can see here. So more on that probably in the next video. So for this video, we're not going to tackle that yet. So now that we have our to-do list, what we need is to maybe expand the card a bit because it's quite small. So let's add some inline style to it, which is, let's say, a width of 300 pixels. And as you can see, it expands as well. So maybe let's make it 600 to make it a little bit bigger. There you go. Now we have our own to-do list. Next, what we need to do is to render our list of stuff to do. So in order to do that, let's create another card section. So like that. Next, what we're going to do is we need to create an area where we can display our to-do list itself. So in this case, we'll use the flex box rather. So what is flex box? So let's head over to Quasar and you'll see that they have a grid system, which is Flexbox. Now, Flexbox is one of the most greatest inventions ever created because it allows you to rearrange content very easily. So as you can see, you can set the direction, you can set alignment like so, and you can set as many things as you want right here. So without diving too much into Flexbox, let's keep it simple and instead let's create a row. And then let's set a justify center, meaning all of our content is compressed to the center of the row itself, making it centered. Next, we're going to create a column. So let's say call 8 or so. Now we have our column. We have a column which is of size 8. So let's say yes, before we render stuff, we need to create a data component first. So let's create a data component here, and as you can see, I'm typing a view data, which is the typical view data declaration, because Quasar is view as well. So we can create a, let's say, a to-do list. So currently it's an array which we will add a specific object. Let's say create an app. So that's our first to-do list. So then what we're going to do is we're going to loop this row. So let's create a v4. Let's say to do task in to-do list. Rather, let's turn it into a item and then index, because we're going to take the index and we're going to use it. So let's add a key with the index, and the next is we're going to render that item. So item dot value. So now we have it here. Next is we're going to add maybe another item. So value build, let's say build an app, and as you can see, now there's two of them. So you will notice that they're kind of in between each other too much, so we can add some space in between them. So let's use the class Q for Quasar, and then py, meaning padding in the y-axis, and then the size, so let's say medium size. And as you can see, now they have a padding in between the top and the bottom. So where do all these py come from? So basically they are style classes, which is, I think it's around here. So it's positioning, let's see, padding, let's try looking for it. Oh no, it's the bottom, padding class. This one, found it. Yes, so as you can see here is a matrix of the padding classes. So what we used is QPYMD. So what that means is we took a Q prefix, we used padding, and then we used the padding Y, meaning top and bottom, and then we appended a size which is MD. So we have MD. So the result would be Q padding for top and bottom, medium. What this means is that for every column we have here, we're going to append a padding on the top and the bottom element to it. So as you can see in the table of permutations, you have a lot of options. You can add the padding for the top, the right, left, or bottom, or maybe the x-axis or the y-axis, or rather you can add padding to the entire element itself, which is denoted by A. Aside from padding, you can also add margin. So with these permutations, you can create paddings and margins between elements in just a small step using this one, as you can see. So going back, let's see. So here's our app. Now we have this one, right? So what we need to do is a way for us to add a task in our app. So what we're going to do is create a form. So first we're going to create another section for the card itself, like so. And then, yes, so what we're going to do is to create a div, which is again a row with a justify content center, meaning all of our content is compressed at the center. Then what we're going to do is we're going to add an input. So going to Quasar, and then let's head to the components. As you can see, we have form components here. So what we need is an input. So here's the input. Going here, you can see there's so many possible combinations to choose from. Like, the combinations is basically amazing. Just look at it. There's icons inside forms. Imagine that. So let's start with simple for now. So let's use the standard one. So let's just grab this one. You just copy, then we just paste it over here. Now we have a queue input. But first, let's add a V model first. So let's create a, let's see, to do task here. And let's set it to an empty string. So let's grab this one, replace this, and now we have an input, as you can see, right there. So we need to, I think, stretch this out. So let's create a div with the full column size, and then let's put it inside there. There we go. Next is we need a button to add our task. So what we can do is, where is it? Let's see. This one, we can use a button. This one looks nice. So let's see where it is. There it is. So let's grab this button right here and this template. So one thing about Quasar is we can modify components. So you can see we created a queue input here, and then we added template. So what this does is we're injecting additional elements inside of an element. So once we hit the save, you can see that there's a button now here. How did that happen? So basically, it is called a template. So a template slot, as you can see. Template slots are used to insert additional elements inside components. For example, the queue input component. So what we did here is we added a button inside the queue input component. Hence, this output here. Now what we're going to do is we're going to add an event to the button. So let's say add item. So down here, we're going to create a method to handle that event. Methods. So let's use add item right here. Next, we're going to create a function. So what we're going to do is the function is supposedly going to add an item to our to-do list. So what we're going to do is we're going to access the to-do list, and then we're going to push an object inside it. So there's the object, we add a value key, and then we append the content of the to-do task, which is right here. So what we're going to do is we add something, and then we click this one, and it gets added to our list. Pretty useful, right? Next, we're going to customize our input. So let's add some placeholder, I think, if that's the right term. Yes, let's check the API itself. So we can see here that it has specific behaviors. So you can add some loading states, lazy rules, and a myriad of options. So every component is completely customizable to your heart's content. You can explore and you can create your own version of it, or you can just mix and match different options. You can play as much as you want with it. So what we need is, in our case, is the placeholder. So I think it's in the style. Yes, no, I think not. Maybe behavior. So let's see. Rules, loading, clearable. How about content? Yes, the label. So it says there label. So let's find the label. Here. So instead of standard, you can, let's say input task. So as you can see, the label changes as well. So do something. So if we click this one, it gets added. Pretty useful, right? So now that we can add items to our to-do task, what we need is a way for us to clear those completed ones. So what we're going to do is we're going to add a button here. So let's see, div class call auto. What call auto means is that the size of our column automatically adjusts to the size of the content inside it, making it much more simpler to modify. So let's add the padding as well to make it even looking. So next, what we're going to do is we're going to add a Q button here, which is the same style as this one, but this time instead of send, let's try check. See if that works. Oh, it doesn't. Okay, so let's take a look at the icon to find out what the icon for the check mark is. So the icon is here. As you can see, it has different icons here. So yes. So for material icons, you can use this one. So we're going to head over to material design, and then we're going to look for some icons. So it says here done. So let's try that again. Let's put done. Oh no, rather here done, and then let's close the element. Let's see if that works. Yes. So there you go. Now that it's there, we have a way to tick off all our completed to-do tasks. So what we can do is let's add some, what do you call this, the divider. We need some sort of divider in between the two. It makes it a bit weird that there's nothing dividing the two. This one, I think it's this one. What it does is the Q separator. So what it does is just it adds a separator line, as you can see right here. So let's try to add a space in between them. So let's put a Q PB MD. So we're adding a padding to the bottom component of the input. So now we have a little bit of space right here. So next, going back, we need to delete that item, right? Once we click this, the app is completed, so it gets removed, or rather the task is completed. So we're going to change this to remove item, and then we're going to add the index to tell our function which item to remove. Next, we're going to create a method here, and then we're going to pass the value from here to here to tell our function that we need the index in order to delete an item. So what we're going to do is we're going to access the list, and then we're going to splice, meaning we're going to remove one element, which is the index itself, and then we're going to delete one element from that. So if we do that, yeah, so there you go. Now it lacks a bit of, let's see, information telling us that there are no more items, for example. So let's add that instead. So what we need is another cue card section right here. But since we have two cue card sections, we're going to add an if condition here to display the content, or rather, this condition is what's going to solve our problem. What we need is to count if there are items in our to-do list right here. So let's check if the to-do list has a content. So meaning we're going to count if there are stuff inside here. Since there are two items, this satisfies as true. Therefore, the content, which is this content right here, gets rendered. But if in case it resolves as false, this content is what is getting rendered. So let's add a row with the same justify center value, and then we're going to create a column which is going to encompass all of the rows, and then we're going to create an element and a container for our text, which is going to be, let's say, h6. So it's a typography class. So let's say no items in the list. So if we do that, since there is a content, it gets rendered. So if we remove this to, there you go. Now you have no items in the list. Now it makes sense. So if we add another item, let's say Quasar, it gets rendered into the different element again. So if we remove that, it re-renders the other one. So what it means is that if we have content in the to-do list here, this element gets rendered. If this has no content, this rendered, or rather this element is rendered. So it's very useful, right? So next is, now that we have our own to-do list app, we can now compile it and then build it as a production ready object. So how do we do that? First, we're going to head over to our terminal here, and then we're going to stop the hosting. Next, instead of using the dev, we're going to use the command build. So what it does is it's going to compile all of our code into a single object, or rather a single webpack chunk object, and then it's going to build it for a specific platform. In this case, single page application, or SPA. So as you can see, it's cleaning up the build artifacts, and then it's compiling all of our UI. And so let's just wait for it to compile. So it says here done. So going back, as you can see, here is the output of the compiled UI. So it has 5 JavaScript files and some minified app and vendor CSS as well. It shows the size as well as the compressed size. So as you can see, the original size is 200 kilobytes, and now the output is 80 kilobytes. So as you can see, there's a big difference in size right here. So now that the app is compiled, you're going to ask, where is it? So basically it's right here. As you can see, this directory is not here before, right? So this directory is where all of our distributed files are stored, meaning all of our build files are stored here. As you can see, it created an SPA folder, which stands for single page application. So this is your final compiled output. This is the application itself, ready for production. So as you can see, the fonts are included here, minified as well as compiled. Same as with CSS, compiled as well. With the icons, they are included as well. And for the JavaScript, they are minified at all. As you can see, I don't understand what's going on. So it's completely minified, as well as this one, and all of them. So basically, what we get is a fully minified, fully compressed, fully production ready application built using your specified build mode. And finally, we have the index.html minified as well. So in order to deploy this application, you need to simply copy and paste it on a web server of your choice, for example, SAMP or Apache or Nginx. So you can just copy this and paste it on a hosting of your choice or anywhere else, and then it will run. So what SPA means is a single page application. So we need a web server for that. Now that you have an idea as to how Quasar works, it's time for you guys to create, experiment, and play with your own ideas. You have the complete documentation over here, which contains a lot of things, and there's so many stuffs here to discover as well. For example, the options and helpers. You have right to left support here. You have SEO. You have Quasar icon sets, animations, transitions. So for the styles, you have shadows, spacing. You even have dark mode. Can you imagine you have dark mode built in? So all you have to do is, let's see, you can create a dark mode for your app, right? So you can imagine what you can do with it. So you have the layout here, you have layout drawer, you have the flex box here, you have so many components to choose from. You have observers here. You also have view directives here. You can morph, you can scroll, you can create ripples, you can create intersections, you can create touch functionality here, as well as plugins. You have dark mode, you have a loading bar, you have session storage for those of you who want to, save sessions or save stuff and persist the data upon closing and opening of the app. You can use local and session storage for that one. You have the full screen as well. You have visibility. You have the notify. So you have security here. You have the Quasar CLI here. There's so many stuffs here. You have commands list. You have TypeScript capabilities as well. You have routing. You have asset handling, boot files, the linter, the store, Vuex store. You can handle Webpack as well. And here you have the different flavors to choose from. You can develop single page applications. You can develop server-side rendering apps. You can develop progressive web apps. You can develop mobile apps. But you have to choose between Capacitor and Cordova. So you have Capacitor here. You have Cordova here. You have Electron apps here. And lastly, you can develop your own browser extensions as well. So also you have app extensions here. So you can create your own extensions of your application and then plug them inside Quasar. Lastly, you have utilities here for date, color, the DOM for morphing objects. You have formatter here for formatting texts. You have scrolling utilities for scrolling between pages or scrolling to specific pixels, and other utilities. As you can see here, you can export file, you have debounce functions, you have throttle, you can generate as many things as you want. So scrolling up, as you can see, there's so many stuff inside the Quasar documentation here. So with all that said, go out there, have fun guys, and create your own applications. You can explore the API right here within this website, in their website rather. You can mix and match different components. You can explore the CLI. You can create as many things as you want. You can maybe create your own server-side rendering app. You can even create a mobile app, whether it be iOS or Android. You can create your own Capacitor app, or you can create a desktop application for Windows, Linux, or Mac OS. So with all of these tools in hand, you can create as many things as you want, all without thinking about how to build this, how to build that. So you don't have to worry about that anymore. All you have to worry about is what you want to build. So again, this is Joshua Hadji, Senior Software Engineer at Pixelate, and I'm here to tell you to go out, have fun, and enjoy Quasar. So, see you later, Pixelators!